To inspect the installation of camshaft bushings 1 through 4, we must look at the underside of the block and concentrate our attention to the main bearing area. We want to be looking at main journals 1 through 4. First, let's take a look at a cam bushing before it's installed. We'll notice that it's just a flat metal band consisting of a hard outer surface, a soft inner surface in which the cam actually rides, and an oil supply hole. Notice that the size of the oil feed passage in the bushing is only about 1/3 the diameter of the oil supply passage in the block. If we were to look into the oil passage of the block with a flashlight, we must be able to see this entire feed hole of the bushing. As long as we can see the entire hole of the bushing, our cam bushings are properly installed. To check the installation of the rear, or the number 5 cam bushing, we must look at the block from a different angle. Inspecting the rear cam bushing, we'll notice that the oil supply hole is centered at the bottom of the bore, and we can look through to the passage behind it with no obstruction for the oil flow coming into the bearing.
In the block.
To do this, once again, we've gone back and used the bolts that we used earlier to remove the original camshaft to use as a holding fixture. And also, what we have to do is just take regular engine oil, and by squirting it down through these holes in the main web, we're going to coat the bearing with oil. The rear bearing will have to coat directly. And by taking the camshaft in our hands in this manner, we're going to start feeding the cam from the front to the end of the block. Extreme care must be taken in installing the camshaft. The surfaces of the bearings are very delicate and soft. The camshaft is hard, and the edge of the lobes are very sharp. You must support the camshaft so that no contact is made between the lobes and the bearing, or you may result in damaging the bearings. If you damage the bearing severely enough, you will have internal engine oil leakage, which will divert oil pressure needed to support your main and rod bearings. Now I move my hand outside the block to support the end of the cam, and that's one of the reasons why we have not installed the rear cam plug yet. Now that we have the camshaft riding in all the bearings, by using the bolts that we installed in the front, we can now turn the camshaft by hand to see what kind of fit we have. The cam should turn 360 degrees without running into any oscillating resistance. Now that we've determined that the camshaft properly fits in our block, we can reinstall the camshaft after applying the proper assembly lube. We're using a Crowler camshaft and valve train system, and like most camshaft manufacturers, with our camshaft, they supplied us with their own brand of assembly lube. On the small block Chevy, we want to first coat the end of the camshaft that carries the distributor drive gear. And it's very simple to do. Use your finger, and you just put a liberal coating on your journals, work some into the distributor gear, put a generous coating on your lobes, the actual cam lobes, and coat it up to the second journal. That's as far as we're going to go at this point. Once again, extreme care must be taken to support the camshaft to keep the lobes from striking the bearings and scoring them. See, now that we have the 2 journals in the camshaft, we have a holding fixture, and we can work on the cam nicely. We can coat these lobes, and we won't get it all over ourselves. It'll still be on the lobes when the cam's in the block. I'm going to go now and support the end of the camshaft inside the block as we did before, to support the camshaft as we move off the journals, to keep our lobes from coming in contact with the bearings. Okay, now we're home free. We've permanently installed our cam in the block, and all our assembly lube is still where it belongs, and we're not wearing it. To prepare the crankshaft for final installation, we need 3 tools. First, we need a gun brush, a triangular hand scraper, and 320 grit emery paper or finer. First, we're going to take our triangular scraper and we're going to very gently scrape the edges of this hole, therefore breaking the sharp edge down into a light chamfer. Once you've used a scraper, you take your piece of emery cloth, holding it over the hole and applying pressure with your fingertip, using short strokes, go back and forth across this hole, perpendicular to the journal. At this time, you will have arrived at a nice smooth edge on this hole. The abrasions from the emery cloth, as you see here, will not hinder your engine at all. You want to take our gun brush, and by applying solvent through the hole, we'll pass the brush all the way through till it extends out the other side of the crankshaft. We want to do several stroking motions for each oiling hole with solvent. Once we've accomplished this, we can spray the entire crankshaft with solvent, or if you're using a cleaning tank, just keep on washing it down with solvent, letting it flow through the oil holes. After that, we can take the crankshaft, let it dry partially, and if you have access to compressed air, it's always advisable to use the compressed air to dry and final clean the oil holes with air pressure. The small block Chevy engine uses 2 distinctively different main bearings in its main bearing set. These are the rear main bearing, which is the wider bearing in the set, and the remaining bearings, which are the narrow bearings. Taking a look back at the rear main bearing, you'll notice it also incorporates this flange. This flange is used to maintain the front-to-back relationship of the crankshaft and the block. Also noted in these bearings that there are 2 different halves of the bearing. You have an upper and lower half. The upper half is a part of the bearing that's installed in the block. The lower half is installed in the main bearing cap. On this particular set of bearings, they've actually distinguished the upper and lower half for you. Along with the information of what size bearing it is, in our case it's a standard bearing, they also have stamped in the fact that this is the upper half of the bearing. Once again, the upper half is a half that not only has the oil feed hole, but on the crankshaft side of the bearing has this oil groove. Let's take a closer look at the main bearing journals in the block. If you notice, on each main bearing journal there is a notch. This notch is used in conjunction with the tab on the bearing. This tab and notch relationship centers the bearing in the journal and also keeps the bearing from spinning with the crankshaft. Once we've washed our hands, it's very simple to final prep the block for the bearings. We take our clean finger now and we want to wipe each journal a few times with our finger. At this point, we can make sure there's no oil or any other type of lubricant in this area. We do not want any lubricant whatsoever between the bearing and the block. We want these to go together completely dry. Also, you want to wipe the back of your bearings and the crankshaft side. Once again, to make sure you've removed dust, lint, any other dirt, check for any type of oil on the back of the bearing, and make sure there are no high spots or rough areas in the bearing. Now that we've done this, we can proceed to install the bearings in the block. Lining up the tab on the bearing with a corresponding notch in the block. Go to the opposite side of the bearing and press the bearing into place with your fingers. Keep pushing on the bearing until the edge of the bearing is below the register of the block. Now go to the opposite side and push the bearing back until you have an equal amount of bearing on both sides above the register of the block. We've installed all of our main bearings in the block. Now we're going to coat them with engine oil. Now we can lay the crankshaft into the bearings. We want to bring it squarely down and rest it in place. At this point, we don't really want to spin the crankshaft because you might actually displace the bearings we've just laid in the block. However, we just want to rock it a little bit to spread the oil out under the bearings. We install the lower half of the main bearings in the main bearing caps the same way we install the upper half in the block. Now what we want to do is liberally coat the main journal of the crankshaft and the associated bearing with oil and drop the cap in place. The area that had the notch with the bearing tang should correspond to the same side of the bearing in the block. Also, if you remember, when we removed the main caps from the block, we stamped the numbers of the position and location on the block. So we should have no trouble reinstalling the caps in their proper location and attitude with the block. There's also a step in the block that the cap fits in. You must make sure that the cap is located in that step. At this point, we can install our bolts. Once again, we want to put a liberal coating on the threads and on the cap where the head of the bolt is going to seat. This ensures us that we won't gall the threads and we'll get an accurate torque reading when we tighten the cap. Now we're just going to take a regular ratchet wrench and bring the bolts down gently. Once again, we want to make sure as we bring these bolts down gently that the cap moves into the recess in the block and doesn't get angled and jammed on one side. And once we finish just snugging the main caps, we're going to get a little brutal. We're going to settle everything in with a hammer. This is fun. Okay, at this point now, you can turn the crankshaft. It's advisable to turn it a few times to spread the oil evenly across the bearings. Okay, at this point, the crankshaft should turn fairly free. It should at least not bind anywhere. Now we're going to take a hammer, medium size. We're going to go and tap lightly on the counterweights. Turn the crank so we can get to the rear half. Tap tightly on them. Turn the crankshaft so you can expose the main caps. Very lightly tap on each one, with the exception of the rear main cap. We can't tap on that because we have a machine face for the oil pump to bolt to. By doing this, though, we've allowed the caps to settle in and the bearings to be locked in tightly in the main web. Now we can proceed to torque the crank. These center bolts in a 4-bolt block have a different torque spec than the outer bolts. The difference is 10 pounds. All of the inside bolts, which were the longer bolts, are torqued to 75 pounds on this engine. The outer bolts torqued to 65 pounds. Whenever you're torquing anything down an engine, you do not go to the full limit of torque on the first application. You want to start out in a 4-bolt block with the inner bolts. We're just going to pull up at this point 25 pounds. We're going to do this to all bolts. Once again, we're starting with the inside bolts all the way down the line. Now we'll go to our outer bolts in the intermediate caps and pull them to 25 pounds. Now that we've gone to 25 pounds, we're going to proceed to 50 pounds. Once again, we're going to work the inner bolts first. Now the outer bolts. Now that we've gotten to a higher torque reading, we should go from outer bolt to outer bolt on the same cap. Once again, let's check our crankshaft. It's still rotating freely. Now we're going to go to 75 pounds and 65 pounds on the outer bolts. Now the outer bolts to 65. With a 4-bolt block, once we've achieved full torque on the outer bolts, we should go back and double check the inner bolts. Once again, they go to 75 pounds. Okay, our crankshaft is fully torqued in place. Let's check rotation again. It's extremely free, which is a good indication. Now to check our actual bearing clearance, we need to one by one remove each main cap, retorque it with plastic gauge in place, remove it again, check the reading of the plastic gauge, reinstall the cap, and move to the next. It's a timely process, but if you want to ensure yourself that you do not have any problems and your crankshaft dimensions are dimensionally correct, this is what it takes. We remove the rear main cap to use our aforementioned plastic gauge to check bearing clearance. We'll use this instead of using measuring equipment, because the measuring equipment, once again, for this is quite expensive, and most people don't have it, and this is the best alternate means to discern your bearing clearance. What you need to do is take a small piece, place it on the journal, lengthwise with the journal. Now we reinstall our main cap, being careful not to displace our plastic gauge. And snug it. Now we have to retorque the cap back to spec. Once again, we'll start at 25 pounds, move up to 50, and then to 75. Do not turn the crankshaft. Now, the next procedure is to remove the main cap. The way the plastic gauge works is it gets pressed between the bearing and the crankshaft and spreads out in width. We'll notice that the plastic gauge has been compressed and spread out. On the edge of the package that the plastic gauge comes in is a scale. It's listed in thousandths. By taking the scale and lining it up against our plastic gauge and comparing the width of it, we'll notice that it's slightly less wide than a 2/1000 indicator and slightly wider than the 3/1000 indicator. This tells us that our crankshaft clearance is actually 2.5 thousandths, exactly what we wanted. So at this point, we want to reinstall the rear main cap and torque it in place, remove the next main cap, repeat the procedure we just did on the rear main, and continue on down till we've checked all our main bearings. Now that we've finished checking our main bearing crankshaft clearance, let's go back to the rear of the block, to the rear main bearing, and check our crankshaft end play. If we take a very close look in this area of the main bearing cap, we can see this shiny edge. This edge is the flange on the bearing we referred to earlier. This darker edge is a corresponding flange of the crankshaft, which rides upon the face of the bearing flange. We're concerned about the space between these two pieces. To measure them, first we'll take a screwdriver, and by inserting the screwdriver between the back of the rear main cap and the flywheel flange of the crankshaft, we'll gently pry the crankshaft back to open up the clearance between the crankshaft and the bearing face. By using the feeler gauges similar to what we used checking piston and wall clearance and ring gap, we can insert this gauge in this area between the two flanges. Once again, the procedure goes to start with a small gauge and work our way up to a thicker gauge to the point where the gauge will not smoothly fit between the surfaces. Once we've ascertained what our clearance is, we can check back in our manual to see if we have proper clearance. Our crankshaft is reading at 9 thousandths, which is within specification for our job. At this time, we can remove the crankshaft from the engine and proceed to install our rear main seal and reinstall the crankshaft permanently. With all the main caps removed, now we must gently lift the crankshaft straight up out of the bearings, taking note if any of the bearings come up with the crankshaft. It's okay if they do, but you want to keep track of them so they don't fall on the floor and become damaged. We're going to have to come back to the rear main bearing area now and clean up any and all oil on the mating surface between the block and the main cap, and also on the main cap itself. This is because we're going to have to apply some sealer in these areas when we reinstall the main cap. The rear main seal is comprised of two lips. We have an outer lip and an inner lip. The outer lip faces the outside of the block and tries to control the amount of dirt or dust that can reach the actual sealing area on this lip. The seal is placed into position on the lip of the block, and take note that this lip is facing the rear main bearing. We rock the seal down into place, and just as we did with the bearings, we want to alternately go from end to end, pressing down until we have the same amount of seal exposed on each end. Now we can put the crankshaft back in the block. Carefully lower the crankshaft straight down into the block and don't turn it. Now it's time to install the lower half of the rear main seal in the rear main cap. Once again, same procedure. We started in, push down on one end, the opposite end, rocking the seal back and forth in the cap until it's properly centered. At this time, we're going to apply sealant to the areas of the rear main cap. You don't have to use a lot of this compound. We just have to put a thin coat in critical areas. First, we'll put a small amount on the cap, and with our finger, we want to dab it on both ends of the seal. This will ensure us that our seal seals continuously around as it mates up with the upper half. We want to spread the sealant out to the ends of the cap adjacent to the seal. Also, if we look at this one offset hole toward the front of the cap, it's the actual passage in which your pressurized oil from the pump is transmitted into the cylinder block. We want to put a nice coating around this hole to prevent any leakage between the cap and the block. At this point, we can apply some oil to the bearing or directly to the crankshaft. Now we can reinstall the rear main cap. As we did before, we're going to relubricate our bolts and the top of the cap where the head of the bolt will seat to ensure us proper torquing. And this time we want to proceed to snug the cap to the block to get our sealer in position and setting up. All I need at this point is a snug fit on the bolts. Now we have to reinstall the rest of our main caps as we did previously. Installing all of them, we'll go back with a hammer, tap on the counterweights on all the main caps except the rear, and then proceed to tighten our bolts in 25-pound increments until we've reached our full torque spec, turning the crank to check for bind after each sequence. At this point, the crankshaft will be permanently installed in the block. We're going to install the sprocket onto the crankshaft, taking note to align the notch in the sprocket to the key in the crankshaft. We should be able to push this with our fingers back until we've engaged the second key. On older crankshaft, you will have one long key. However, once the sprocket is into position on the crankshaft, you'll run into an interference fit. It is a press fit that retains the sprocket to the crankshaft. To finish installing this, we're going to need a brass drift and a medium-sized hammer. We're also going to want to lubricate the crankshaft behind the sprocket at this point to aid in installing the sprocket. We're going to take our drift and lay it flat against the sprocket. We don't want the drift to contact the teeth of the sprocket because you might chip or break them. We want the drift to hit more towards the area just adjacent to the crankshaft. We're also going to tap lightly with a hammer, alternating from side to side until the sprocket is firmly against the front flange of the crankshaft. When the sprocket has been fully engaged in the crankshaft, we'll have a different sound on the drift. If you notice, we had an extremely sharp sound at this point. That indicates that the sprocket is fully seated against the front face of the crankshaft. To install the camshaft sprocket, first we want to rotate the crankshaft around so that our indexing mark lines up with the center line of the camshaft. This is a relationship we want so that the reference mark is in direct line with the center of the cam. And locating this dowel pin on the camshaft to the corresponding hole in the sprocket, like this, and taking one bolt, inserting it at any of the three holes, and threading in a few threads with our fingers, we can now take the camshaft and sprocket and turn them in unison until the corresponding mark on our camshaft sprocket is in line with the crankshaft sprocket. Now we can remove the bolt and our sprocket. We're going to take the assembly and hang it onto the crankshaft sprocket, maintaining our alignment point on the camshaft sprocket facing straight up toward the crankshaft sprocket. We want to hang this in such a way that we retain the alignment between these two markers. At this point, the camshaft sprocket should line up directly on the dowel on the camshaft. Now we can install our three attaching bolts and tighten them. At this time, we need to stop and take a look at our camshaft, crankshaft, sprocket alignment. In order to do this, we must first push the camshaft sprocket firmly against the block. Then, by taking a straight edge, or in our case a machinist square, we want to lay the square up against the crankshaft sprocket and follow our line of sight down to the camshaft sprocket. They should be both touching the edge of the square. If not, what normally happens is the block you have was designed to use a thicker camshaft sprocket, and the camshaft sprocket will be closer to the block than the crankshaft sprocket. If this is your case, you will need to purchase a camshaft shim. The shim looks like this and would be installed between the front of the block and the camshaft sprocket. They come with instructions, and you follow the instructions to the letter.